Collections in Java. The collection in Java is a framework that provides an architecture to store and manipulate the group of objects. The collection framework provides many interfaces: list, set, and map. These are the main interfaces provided by the collection framework. List collection classes are ArrayList, linked list, and vector. These collection classes are ordered set of collection classes. Ordered collection classes in the sense in which we are going to insert into the collection class same order it will store internally. On the other hand, set collection classes like hash set, linked hash set, and tree set are unordered. And the map collection classes are hash map, linked hash map, tree map, and hash table, or store the elements in the form of key and value pairs. Let's discuss difference between collection classes and arrays. Why we go for collections API in comparison with arrays? Arrays are fixed in size. That is, once we create an array, we cannot increase or decrease size of the array. I mean we cannot modify the capacity of the array depending on our update operation, whereas capacity of the collection classes changes depending on the insert operation. Array can contain both primitive data type as well as objects. However, collection classes only supports object entries, not primitive data types. Arrays can hold only homogeneous data elements. I mean set of similar data types, whereas collection can hold both homogeneous and heterogeneous elements. If you are using JDK 1.5 and above version, then we are supposed to declare collection classes with type of data we are going to store into the collection with the help of generics. Otherwise, it will give warning. Let's discuss in the example. Collection classes provides set of methods to perform add, remove, update, and retrieval of elements. So it is easy to use collection classes compared to arrays, and collection objects can be transferred over the network. So these are the main difference between arrays and collection classes. This is the collection API hierarchy in which list and set interfaces extends collection. Classes ArrayList, linked list, and vector implements list interface, which are ordered collection classes. I mean which will maintain insertion order. Set collection classes like hash set, linked hash set, and tree set, which implement set interface. All set collection classes are unordered. Let's discuss individual collection classes in brief. ArrayList class implements list interface. It uses dynamic array to store elements in of different data types. The ArrayList class maintains the insertion order and non-synchronized. In the sense, ArrayList is not thread safe. The elements stored in the ArrayList class can be randomly accessed. Let's discuss set of operations provided by the ArrayList with an example. We can create ArrayList object using three constructors of the ArrayList. Constructor without any argument, I mean default constructor. I can use constructor with one argument, that is the initial capacity of the ArrayList. If you are sure that ArrayList contain minimum elements like 1000, in such a case we can declare ArrayList with 1000 elements. We can use one more constructor by passing collection class as an argument. That is, if you want to move already existed collection object into the new ArrayList, we can pass as an argument while creating the ArrayList. ArrayList supports add method to add heterogeneous elements. In the sense, I can add integer values, string values and floating point values. ArrayList store mixed data types. If you are using JDK 1.5 and above versions, it will give warning. Why? Because we are supposed to declare ArrayList of type in which it is going to store. I mean type of the element in which it will store. Here Eclipse tool giving warning for all add methods. Okay, in this example I am storing three integer values and one string and floating point value. If you try to execute this example, this print statement will give the output of 10, 20, 30, hello and 10.45. We can remove the element by passing index of the ArrayList. In this example, I am removing element of the ArrayList at index 2. So, integer value 30 will be removed from the ArrayList. So, if you try to print this system.out.println of this ArrayList, it will give 10, 20 hello and 10.45. We can insert an element in the middle of the ArrayList by passing index. In this example, I am inserting 40 at the second position. So, if you print this system.out.println of this ArrayList, it will give 10, 40, 20, hello and 10.45 as elements of the ArrayList. ArrayList allows us to retrieve elements using get operation. Get will take index of the ArrayList. Here I am retrieving second element by passing index is 1 and fifth element by passing index is 4. So, if you want to perform any retrieval operation, so the time taken for first position element, the time taken for retrieval of element for the time taken for retrieving element of the array list at position 1 or at one growth position is same. So if you are performing frequent retrieval operations, then ArrayList is preferred collection class. We can use for each statement to retrieve all the elements of the array list. If you try to execute, it will display content of the array list as I mentioned in the comments. Let's discuss set of methods available in the array list to perform insert and update operation of the array list. Array list provides three constructors to create object of the array list. Array list with the default constructor, that is capacity of the array list is 10 prior to the insertion. I mean, if you are trying to insert first element prior to the insertion, that is add method of the array list will create array of size 10 and then it will insert first element at 0th index. And there are other constructors available in the array list are constructor by passing size, capacity of the array list, that is initial capacity, that is 1000. Suppose if our array list may contain 1000 elements, suppose if you are sure that our array list contains 1000 elements, in such a case we can declare array list of 1000 capacity while creating the array list as shown in the example. I can use third constructor, that is array list constructor, as collection class as an argument. That is, if you want to move already existed collection class into the new array list, I can use third constructor. ArrayList provides add method to insert heterogeneous elements. If you are using JDK 1.5 and above versions, we are supposed to declare array list with the type of elements, otherwise it will give warning. Here our Eclipse tool giving warning for all add methods of the array list. In this example, I am inserting 10, 20, 30 integer values and string hello and floating point value 10.45. So if you want to print the array list by using system.out.println, it will show 10, 20, 30 hello and 10.45. So 10 is at index 0, 20 is 1, like that it will store into the array list. We can remove an element from the array list with the help of remove method by passing the index. If you want to remove an element internally, the shifting of element will be done. In this example, if you print the array list, the 30 will be removed from the array list and the next position element will be moved to the previous position. can insert an element in between the array list. In this example, I am inserting 40 at position 2, index 1. If you print this array list, it will print 10, 40, 20, hello and 10.45 as an elements of the array list. Array list implements random access interface, which is a marker interface. It allows us to retrieve elements with respect to positions. If you want to retrieve element of first position or even element with one growth position, the time taken for all retrieval operation is same. ArrayList is preferred collection class if our frequent operation is retrieval. I can retrieve all the elements of the array list with the help of for each statement like this. So if you want to execute this example, it will print content of the array list as shown in the comments of a sysout statement. So if you want to create array list object, initial capacity of the array list is 0. If you start inserting element into the array list prior to the first insertion, it will create array of size 10 internally, and it will start inserting the element one by one into the array as shown in the PPT. So once the capacity is full, if array stores 10 elements, if you are trying to insert 11th element, it will create another array of element 15. The capacity 15, and it will move the elements of the previous array into the new array and start inserting the next element in the 11th position onwards. The capacity of the array list changes dynamically depending upon our insert operation. Let's discuss how array list changes capacity dynamically. If you want to create an array list object, initial capacity of the array list is 0. If you start inserting element into the array list prior to the first insertion, it will create an array of size 10 and start inserting element into the array. If the size reaches its capacity, then it will create one more array of element 15 using formula as shown in the PPT. So it will changes the capacity dynamically depending upon our insert operation. So capacity of the array list changes 15, 22, 33 like that depending upon our insert operation. This is the method which will calculate the new capacity. So let's discuss how array list changes its capacity depending upon our insert operation. There is no method in the array list to get capacity of the array list. So in this example, I am using reflection API to get the capacity of the array list. Capacity test is the method which will perform some add methods and it will retrieve the capacity of the array list. In this example, I have created a new array list and I am showing initial capacity. Initial capacity is 0 and I am performing add operation 25 times. So I am adding 1 to 25 into the array list and I am printing capacity of the array list as we do insert operation into the array list. If you want to print the elements of the array list, it will inserting element 1 at index 0, 2 at index 1. Like that it will insert element 10 at index 9, that is capacity 10. After array list is full, then it will create one more array internally to insert next subsequent elements. So while inserting element 11, it will increase the capacity by 15, and after 15th element it will increase the capacity by 22. After 22 elements it will increase the capacity by 33. Like that it will keep on increasing its capacity depending upon our insert operation. So this is the end result of the array list, which will store 25 integer values, that is 25 elements. Let's do some remove operations. I am removing first 20 integer values from the array list by passing index 0. If you remove first element, internally it will shift second element into the first position. Like that it will shift all the array elements into the previous position. If you print the array list after removal operation, it will show 21, 22, 23, 24 and 25 like this. But the capacity is same, that is 33. Let's see the output. That's how array list changes its capacity dynamically depending upon our insert operation. Main points in this array list. Array list allows insertion order. I mean, it will store elements in the same order in which we are going to insert, and it allows duplicates, and it allows null values. Array list implements random access, so one can randomly access the elements of the array list irrespective of the position. The time taken retrieval operation of first position and even at one growth position is same. Prefer array list when frequent operation is retrieval operation. Insertion and deletion of elements in the middle of the array list requires shifting of elements. Array list is the worst choice when frequent operation is update. ArrayList object can be transferred over the network. Why? Because it implements clonable and serializable interface. Thank you.